Hello everyone, my name is Atanas and I'll be talking about social learning with bounded rationality, negative reviews persist under US first. This is joint work with Baek from NYU and my advisor Thodoris Lykouris from MIT. So let me start by talking about how do we as customers learn from reviews. So nowadays product reviews are ubiquitous on a variety of online platforms, ranging from electronic commerce to accommodation platforms to recommendation platforms. But in order to get a better sense of how product reviews impact our purchase decisions, suppose I'm looking for a hotel on TripAdvisor. So let's say I want to stay in the area of Times Square. So I search of Times Square and I stumble on the Crown Plaza Hotel. So I see that this hotel has 4 out of 5 stars and about 12,000 reviews. But before booking the hotel, I'll probably also read some of the individual reviews. So by default, TripAdvisor shows you the most recent 10 reviews on the first page. So I'll probably read the first few reviews in detail. So after reading the first review, I actually see that it's quite negative. So maybe after reading this review, I probably won't book the hotel, or maybe I'll read a few more reviews. But given that the general sentiment of those reviews is that they're on the more negative side, I'll probably won't book the hotel after all. So as we saw in the TripAdvisor example, the individual product reviews did impact our decision. So what are the main mechanisms through which reviews impact purchase decisions? So first of all, it's been empirically observed that the average rating of the reviews matters, and also that lower ratings lead to lower purchases. Interestingly, it's also been observed that the individual reviews themselves matter because customers like to read textual information. And also it's been empirically shown that the individual reviews could actually have a higher influence on customers' purchase decisions than the average rating itself. And lastly, given that customers have bounded time and computational power, they're only able to read a few reviews. And a survey showed that 80% of customers read less than 10 reviews. So there has been a lot of empirical work establishing those mechanisms, but what about theoretical models incorporating them? So in regards to the first two, there has been many theoretical works studying those mechanisms. And in particular, those have been in the area of social learning from reviews. So this area is concerned with the general model where customers learn about the product quality by reading reviews left by prior customers. And the main overarching question is when or under what conditions the customers successfully learn the product quality. And here are a few papers that study this general model. So even though the first two mechanisms have been studied extensively theoretically, the fact that customers read individual reviews in detail and that they only read a few reviews has not been explored that much from a theoretical standpoint. And incorporating those two constitutes our main modeling contributions. So what would be the implications if customers rate a few reviews? So let's go back to the Crown Plaza Hotel from TripAdvisor. We saw that this hotel has an average rating of 4. We also looked at some of the individual reviews. So we saw that the first 4 reviews that we read had those ratings. And also, it's not hard to compute that the average rating of those 4 reviews is 2.5, while the average rating of all of the reviews was 4. So did we just get unlucky that those 4 reviews happen to be particularly bad? Or is there some more fundamental issue with how the platform shows reviews? In order to understand this, I would now like to conduct a short quiz. And I hope that you are comfortable with taking expectations because I want to ask you the following question. Suppose that X is the average rating of the first 4 reviews shown by the platform. And I'm taking the expected value of X over all of the days the product has been on the market. Do you believe that the expected value of the 4 reviews is going to be A, equal to the average rating of all of the reviews, B, smaller than the average rating, or C, greater than the average rating? So is the question clear? So who thinks the answer is A? Please raise your hand. Okay, who thinks the answer is B? Please raise your hand. Okay, who thinks the answer is C? Please raise your hand. Okay. So surprisingly, the answer is B. The average for the first 4 ratings are smaller than the average rating. But what is that? So recall that TripAdvisor does not just show you random reviews. It shows you the most recent reviews or the newest reviews. So this suggests that showing the newest reviews has some fundamental issues with it. And in the next slide, I'm going to demonstrate a simple theoretical model that could illustrate how we can capture those issues. So let's consider a warm-up example in which each customer reads only a single review. And for simplicity, each review is either positive or negative. So suppose that each new incoming review is negative with probability 1/2. What this means is that if the product has many, many reviews and the platform selects one review at random, the probability that a randomly selected review is negative is equal to 1/2. And this probability is in some sense the equivalent of the average rating in the TripAdvisor example. Also suppose that if a customer comes and they see a positive review, they purchase with probability 2/3. And if they see a negative review, they purchase with a smaller probability of 1/3. And under this model, we're interested in what is the probability that the newest review is negative. The previous TripAdvisor example suggests that this probability should be greater than 1/2. And in order to verify that, we need to analyze how the customer's purchase decisions impact the next review that's going to be shown on the platform. So to do this, we consider two cases. The first case is when the newest review is positive. In this case, we could either obtain a purchase with probability 2/3 and a new review, which is equally likely positive or negative, or a no purchase with the remaining probability of 1/3, in which case the newest review remains positive. And there are cases when the newest review is negative. In this case, again, we could obtain a purchase, but this time with a smaller probability of 1/3 and a new review, which is equally likely to be positive or negative, or a no purchase with the remaining probability of 2/3, in which case the newest review remains negative. Observe that the probability of replacing a negative review is 2 times smaller than the probability of replacing a positive review, which means that negative reviews will persist longer in the system as the newest review than positive reviews. This implies that this probability should be greater than 1/2. And in fact, using those specific numbers, it's not hard to show that the newest review is negative with probability exactly 2/3. While if I show the random review, it was negative with probability 1/2. This establishes that negative reviews are more likely under the newest ordering than under the random ordering, which constitutes one of our main results, and we show that this holds in a much more general model. So next, I'm going to talk about our main questions. So our main overarching question is the newest first review ordering problematic? And we showed, and our main result is that newest reviews always lead to fewer purchases than if customers rate random reviews, and we term this phenomenon the cost of newest first. Moreover, we show that newest reviews can be arbitrarily worse than random reviews for the platform's revenue. And given that this problem exists, it's natural to ask whether the cost of newest first can be mitigated. And we show that yes, if the platform uses dynamic pricing, then the revenue of showing newest reviews is at least 1/2 of the revenue of showing random reviews. And along the way, we identify an interesting structural property of the optimal dynamic pricing policy, which is that the purchase rates are the same for all review states. And given that we studied this phenomenon theoretically, it's also natural to ask whether the cost of newest first can be observed in practice. And by studying hotel review data from TripAdvisor, we're able to corroborate our theoretical. I'm next going to talk about our main model. So we consider a sequential model in which there is a platform that offers a product, and at every round, there's also a customer that arrives. The customer has bounded rationality in that they only read C reviews by the platform. And we assume that the customer has a valuation for the product, which is equal to the sum of mu, which is the true product quality, and theta, which is their customer-specific valuation. Note that the true product quality is unknown to the customer, so the customer doesn't have full access to their customer evaluation. And in order to make a purchase decision, they need to read the reviews in order to estimate that product quality. So to do this, we assume the customer has a prior beta AB on mu. And as I said, they read only C reviews. For simplicity, we assume that each review is positive or negative, or 1 or 0, and that the platform has a review ordering policy in place. The 2 review ordering policies that we're going to consider are first, showing the newest C reviews, and 2, showing random reviews. Where under random, we assume that every review is drawn from an independent Bernoulli sample with mean equal to the true product quality mu. Given their prior and the reviews that they read, the customers form a natural posterior given by this formula. And after this, they map this posterior to an estimate for the true quality through this arbitrary mapping H. And they form their estimated valuation where they replace the true product quality mu with the estimator H. After that, the platform offers them a price, and the customer purchases if and only if their estimated valuation exceeds this price. In case of a purchase, the customer leaves a new review for the product, and this review is drawn from a Bernoulli sample with mean equal to the true product quality mu. One important thing to note about our model and some models from prior work is that we assume that the customer-specific valuation is not reflected in the review itself. And one way to think about this assumption is that given that we assume that customers read reviews in detail, by reading reviews in detail, they're able to separate out the customer-specific valuations of prior customers and only have access to the component coming from the true quality. So I'm next going to discuss the relationship of our model related to prior work. So recall that our 2 main modeling contributions is that we model customers that read only a few reviews, and also the customers read reviews in detail by reading textual information. So there has been a line of work that studies customers that read all of the reviews and use fully Bayesian updating. And here are a few papers that study that. Like one practical issue with that is that customers are bounded in their time and computational power. And there has also been a line of work that studies customers that only read the average rating and don't focus on the individual reviews themselves. And here are a few papers that study this model. So one issue with the average rating is that it could suffer from the so-called self-selection bias, which is the phenomena that only customers that have a high enough valuation are going to purchase the product, and they're going to be the only ones giving review, which will lead to a natural upward bias of the average rating. So one way to think about our model is that we're somehow a middle ground in the sense that the customers in our model are able to incorporate the average rating to their prior mu, and this prior can be incorrect, and therefore we could be robust to self-selection bias. And also, customers in our model read a few reviews rather than all of the reviews. So I'm next going to restate our main results under our more formal model. So we're concerned with the cost of newest first, which we define to be the ratio of the revenue under when the platform shows random reviews divided by the revenue when the platform shows the newest reviews. And here we define the revenue as a steady state long-term average of the system. And under this ratio, we show that under static pricing, the cost of newest first is always greater than 1 for any non-degenerate instance. And moreover, the cost of newest first can be unbounded under static pricing. And even if I allow the platform to optimize its prices over a static price over random and under newest, it can still be unboundedly large. In terms of mitigating the cost of newest first, we show that if the platform uses dynamic pricing, so if they range the price depending on the review ratings they show, we can show that the cost of newest first is at most 2 under the optimal dynamic pricing for any non-negative customer value distribution. And also along the way, we identify an interesting structural property of the optimal dynamic pricing under newest, which is that the purchase rates should be equal across all review states. And lastly, thirdly, we obtained empirical support from TripAdvisor with 24 hotels, in which we observed that the average rating is lower under newest than under random in 22 out of those 24 hotels. And on average, newest has 0.15 stars lower rating than random. And lastly, given that there has been some empirical work that shows that customers prefer to read newer reviews than older ones, in our model, we consider modeling extension to time discounting customers and show that even under this model, newest first is not the best policy. So in the rest of the talk, I'm going to focus on the first 2 results, and in the last 2, I refer you to our paper. So I begin by talking about the cost of newest first under static pricing. So recall the result is that the cost of newest first is strictly greater than 1 for any non-degenerate instance. And I'm going to briefly talk about the proof intuition. So recall our example, our warm-up example from earlier, and suppose that this is achieved when the platform sets the same price of 1 regardless of whether the review is positive or negative. In this case, the probability of replacing a negative review is smaller than the probability of replacing a positive review, which would mean that negative reviews will persist longer under newest than under random. And this would imply that newest will spend more time in low revenue states than random. And therefore, this would imply the result. And we show that this can be generalized to an arbitrary number of states. And the second result here is that the cost of newest first can be unbounded under static pricing. And it's not hard to show that there exists a price such that a negative review, the probability of replacing a negative review is negligibly small, which would mean that once the review becomes negative, it will almost always stay negative, leading to very low revenue. So I'm next going to talk about our dynamic pricing results. So we show that the cost of newest first is at most 2 under the optimal dynamic pricing for a non-negative value distribution. So recall that the issue with static pricing was that the purchase probability for a positive review was higher than the purchase probability for a negative review, which induced negative reviews to persist longer. So what we show is that under dynamic pricing, the optimal policy is to set prices so that the purchase rate does not depend on the reviews, and it's the same across all review states, which means that we'll set lower prices for low reviews and higher prices for high reviews. So in this example, we'll set, for example, here we'll set a price higher than 1 when the review is positive and a price lower than 1 when the review is negative, which would imply that the purchase rates are the same for both positive and negative reviews. This would imply that newest and random would spend the same amount of time in each review state. So I'm next going to talk about the main intuition behind how we bound the ratio of the revenues by this factor of 2. So observe that under random, the price that we set does not affect the review that's going to be shown next, or in other words, the reviews are exogenous function of the history. This means that optimizing revenue under random is achieved by simply setting the revenue maximizing price in each state. On the other hand, under newest, the price does affect what the next review is going to be, or in other words, the reviews are endogenous. And what we show here, as I said, is that optimizing revenue under newest is achieved by setting prices so that we equalize the purchase rate along each review state. So given this, as I said, newest and random will spend the same amount of time in each state, and therefore, in order to bound the revenues, intuitively, what it remains to show is to only bound the ratio of the prices they set. So in other words, we need to bind the ratio of the revenue maximizing price to the prices that equalize the purchase rates. And intuitively, we can show that this ratio can be decomposed into two components, where the first component intuitively comes from the customer specific valuation of the customer. And the second one comes from their belief about mu. And we can show that in expectation, each of these components is at most one. And this is the high level intuition. I refer you to our paper for more details. So I'm next going to provide a summary and some future directions. So in summary, we established that the cost of newest first exists and that it can be arbitrarily bad. We also show that the cost of newest first can be mitigated under dynamic pricing. And we also show that this cost of newest first can also be observed in real data, in particular on TripAdvisor. In terms of future directions, there are a number of interesting directions to consider. So first of all, how would the self-selection bias that I talked about interact with the cost of newest first? Secondly, how should a platform consider its review ordering policies when they're offering multiple products? So in this model, we only studied a single product. And thirdly, what would be some other ways to disseminate relevant information from reviews? For example, nowadays, generative AI is very popular on platforms like Amazon. And lastly, on the more technical side, most of our analysis analyzes Markov chains with stochastic waiting times. And it would be interesting to see if this kind of analysis can be extendable to other applications as well. And this concludes my talk, and thank you for your attention.